And I think it is critical that you understand that you need to learn how to automate, right? And I know a lot of you are afraid of programming. Um, and I think you need to probably think about getting over that fear. You don't need to be, an amazing computer science programmer and do, program machine learning and AI, but you need to learn how to script, and you need to learn how to put together, I need to grab this information off the computer and I need to poke it into these variables, and I need to be able to use those variables to then automate the tasks that would have taken me, 30 hours this week, and I need to do all that in 6, because I can code, 20 lines of script. Okay. Yeah. Anyways, so just be aware of that, right? And that's part of the idea of this chapter is that automation in the cloud is key, right, to being a good cloud architect. All right. So we're going to talk about terminology related to automation services. We'll talk about the benefits of infrastructure as code. Okay. Speaking of infrastructure as code, again, one more sidetrack. Even Cisco, right, the world's largest hardware manufacturer of networking equipment, understands that infrastructure as code is where everything is going. Okay. So, 5 years ago, it was difficult to program a Cisco switch with Python. Nowadays, it's required for you to know Python, some amount of Python, in order to get a CCNA, right? To get that first, level of certification through Cisco, right? Because it is ingrained in their new systems. Okay. So infrastructure as code, and that the idea of infrastructure as code is this idea of spinning up virtual switching and routing and load balancers and VMs and all these crazy things running scripts versus me clicking on, buttons and making selections and stuff like that. All right. So we'll talk about some popular automation tools. We'll identify some maintenance tasks that are well suited to automation, right? Right. If you've taken my IoT class, so we use a book called Automate the Boring Stuff, and that's, right, think about maintenance tasks, anything that's boring, right? That should be automated. Right? Anything that requires me to run around to a computer and click and open and, click and save and, right, that kind of stuff, right? There's no brain power being used there. There's no, right, we can, we want to try to avoid that kind of thing, right? And be able to automate that. And then prioritize updates, right, according to criticality. So we're going to learn how to, and you'll play with that, I guess, in your labs, right? All right. So we'll talk about patch. I don't think we'll do this until next class, right? But patch and update methodologies, like how should we patch these things? We'll talk about automating patch management, right? Which is a common technique in the on-prem world as well. So you're going to want to make sure you do that. Implement automation using cloud security tools, techniques, and services. We'll analyze the impact of automation on cloud security. And you'll see, again, another place where it is so much more efficient to have a computer watching what's going on in your network than for you to sit in front of a monitor and watch it, right? You want the computer to be watching and tell you when there's a problem, right? Or tell you when it thinks there's going to be a problem, so that you can react appropriately. Okay. Yeah. So there you go. That's what we're going to do. So, in our world, automation, right, is using technology to perform a process or procedure with minimal human intervention. Usually it boils down to the human launching whatever tool that you've created. Okay. Examples of where you've seen automation in the real world, right? Self-parking cars, right? So Siri, when you tell Siri to turn on a coffee pot, right? I like this, they have drone package delivery, which we don't have yet, right? But it's coming. Drone package delivery, robotic package delivery. A lot of that stuff is on its way, right? So some thoughts on how we would do this in the cloud. We could create, clone, or shut down VM instances or a server cluster, right? So we can run scripts and it'll launch certain type of VM, and it launches it the same way every time. It's really consistent. It's really quick. It doesn't. We don't tend to have errors there unless we've done something wrong in the code. But if you have a human, let's put it this way, let's say I have a code that'll launch a VM instance, and it's set up exactly the way I need it to be set up, and I need to run 100 of those this week. And either I give you the code, or I tell you as a person, right, as a technician, I need 100 of these exactly the same, go, right? What's the likelihood that the human will get through that without messing something up somewhere, right? It's not likely. And I'll tell you why it's not likely, because it's easy. I call it fat fingering, right? Which I'm allowed to call it fat fingering. Little stubby little fingers here. The idea of that though is, right, I can make, if I'm supposed to type in 3.6, I could actually type in 6.3. I could put a period in the wrong place. I could put a slash in the wrong place, right? I could create all kinds of errors. I could click the wrong button. I could forget to click a button, right? And that happens a lot when people think, well, I know the process, I'm just going to do the process, and they don't create a checklist and check it off every single step. It's really simple to make a mistake, right? Super simple to make a mistake if you don't have checklists and things like that. However, if I gave you the code that would fire those off, literally you would run the code, and a half hour later, all 100 of those VMs would be created and ready to go. Like literally they'd be done. So I think that's a big deal, right? This idea that, if I have tools that will help me automate these things, great, right? In this class, we've been doing things all by hand, and we're doing one-offs so that we can learn how it works, right? If you don't know how it works, right, probably not going to want to automate it yet, right? So you got to know what's going on in order to automate it. And then once you've got a good grasp on how things work, and you can do them, and you're comfortable with them, then creating the automation is a whole lot simpler, okay? The other thing is, and I'm giving you a simple example of just firing up a VM, but you can fire up virtual networks. You can do really extensive, really complex environments. You can have multiple VMs, multiple switching, multiple routing, load balancing, all kinds of craziness that you could automate with scripting, right? With automation here, okay? Right, and I think I've already kind of talked about, we get bored or we make mistakes. Computers, right? If you tell it do XYZ, it does XYZ. You tell a person do XYZ 100 times, right? You may get two XXYs, or XYY or XZZ, or we get something weird, right? So anything where there's this chance of mistakes, right? If you're doing one-offs, automation is not going to give you a lot of advantage, right? If I'm going to go sit down and I'm going to fire up a VM, I'm going to do this, this, and this to it. Right? Unless it's a pre-done template that you already have done and you already have automation for, right? That's not necessary. But if you're doing 5, 10, 15, automate, right? When you automate, you get faster deployment, you get better control, you get lower costs, right? More secure, right? You get all kinds of goodness when you can automate things. So some of the things that you can do with automation tools, right? So this is just specifically maintenance and security tasks, right? So snapshots and backups, we can automate all of that. We can clone, we can resize, we can remove resources, right? We can use that based on triggers, right? So if this happens, clone this. If this happens, resize this. If this happens, take it away, right? And that's that kind of elasticity component. And some of that stuff is built into how cloud works, but that's part of automation, right? Elasticity. If I'm getting pounded, my website's getting pounded, like create another one and serve both of those, right? If those two are really busy, fire up a third one and do that. And then when they're not as busy as they need to be, go back to 2 or go back to 1, right? That's automation, right? So those things kind of count for this. Shut down, restart VM instances. Something went wrong. Can we restart it? Something, we need to shut these things down at a certain time. We don't need them anymore, whatever the case is. Right? In the security world, like detecting signs of attack, right? So intrusion detection and intrusion prevention, those types of systems, they will be able to monitor the network and look for, using heuristics, kind of find issues and be able to alert you of a potential issue, right? right? Or be able to take disparate information and put them together into a, hey, you have a problem here that you would not normally see as a human unless you were watching all of these things all the time, which is not going to happen. Okay. Um, right. I can also say, hey, if we've discovered malware on a piece of equipment, sorry, if we've discovered malware on a piece of equipment, then I can, have it automatically quarantine that system versus, hey, tell me that I have a problem and then let me go take care of it. Okay. We can update and manage security rules as well. Right. So automation, you need to think of automation as your friend, and as your, I don't know, I would say your ticket to the big time. Right. That's going to be, to me, right. That's going to be the difference between um, a quality technician versus somebody who's done this for a long time, right? I know when I was looking for employees, I'm always looking for people who can make things run quicker, more organized, right? Um, you know, get things done during the week instead of on the weekends. So that's kind of a typical IT problem, right? So a lot of weekends lost. But automation, we use automation a lot to reduce our weekend work times to the point where it was very rare that we had to do anything on the weekend. All right. So infrastructure as a code. Okay. So these things we call run books, right? A run book is a collection of physical or digital documents. And what they do is they outline the precise steps to complete procedures or operations in a specific IT environment. Okay. So to me, a run book would be a policies and procedures manual, right? If I'm going to install antivirus, here are the 22 steps that we do in this office, right? And the reason why we do that, and the reason why we have these documentation, these policies and procedures, is I can go into any environment, and we did this. This is something that I did when I was working in St. Louis, right? So I worked for a company called CIS-2636 in St. Louis, and we took care of a ton of customers, and we had 5 people, right? 5 technicians on staff, and when I got there, they didn't have any kind of procedurals. There was no procedures whatsoever. So if you were told to go install antivirus, like, hey, this customer called and they don't have antivirus on the machine, right? There was no instruction for the technician on what they were supposed to do. They literally would go there and they would install whatever they were comfortable with, right? So, and when we had a discussion about that, just one topic, like that's an easy one to talk about, like, right, Nick, when you go and do installation of antivirus, what do? Well, I go and download the free AVG and dump it, right? What are you talking about? And then the other person would go and they would use pandas, and then the other person would use something else. Everybody did something different, and they did it because that's what they were comfortable with. And and there was no documentation that said what they were supposed to do, right? Nothing. Right. So from that conversation, I was like, man, we really need documentation. We need to have this procedure. So we started a 3-ring binder, and every person was tasked each day. Anything that if they got signed a ticket and they had to do something, I need to do a disk cleanup, or I need to clean up a virus, or I need to install antivirus, or I need to install malware, or I need to set up, a wireless access point. Whatever it was you did, before you left, you would look in the book and see if we had a procedure for that. Okay. And if we don't have a procedure for that, then you write out exactly what you did for that customer. We had a form that they would fill out, and then that became the procedure. Whether it was right or wrong, that wasn't important at the time. Every day that you do something new that's not in the procedure book, you would write down the steps and stick it in the book as the procedure. Okay. So it took us maybe 3 months, maybe 4 months to get pretty much all the procedures that we were going through, um, or that we did on a normal basis, written down and in this book, physical book, right? And then the other thing that was part of this is if somebody, the next person that needed to install antivirus, so the first person that installed antivirus, right? I preempted that one because basically the first person that was supposed to do that, I said, this is how we're going to do it, right? Because we have a system that antivirus is included as part of the system. So we shouldn't be using anything else other than what we have in our system because we monitor it in our system. So we used the documentation from the company. We wrote the procedure and that became the procedure. Now, every single procedure could be challenged, right? So somebody, was going out and they had to do, say, a disk cleanup, and they brought out the thing, and they're like, "This is only doing half of the job," right? So then they would say, well, they could add to the procedure additional steps that they wanted to do, and then if they did any kind of addition, then that would be reviewed on every Friday. We review the policies that were edited, right? And like I said, it took us 3 months, 4 months with 5 people doing this, right, as a daily task. It took maybe 15 minutes to 30 minutes per day to do this task, right? But by the time we got done, we had essentially what's called a run book, right? Policies and procedures. And everything, anytime a new person would come in, right, to the environment, their first week was simply read the book, right? It's super boring, but read the book, right? Here's how we do things, right? And then anytime you get a ticket, you find the procedure and you duplicate that procedure, okay? If you find a problem or an error, then that can be highlighted in those Friday meetings, okay? And what was nice about this is once we got done, everything was super consistent, right? Every single customer got the same setup, the same quality, the same results from us providing all these policies and procedures, okay? It was probably the single most important thing I did at that company, right? Was to give them the documentation they needed for any person to come in and be able to operate. As soon as they read the procedure, they would be able to duplicate what we did last week, what we did 2 months ago, what we did 6 months ago, right? There was no question as to what am I supposed to do now, right? Here's the book, find the document, right? If there's a document missing, right, bring that up with the director, right? In that case, it was me at the time. Bring that up with me if there's something missing or you don't know where it's at, and we'll get, we'll either create it right then or we'll find the appropriate instructions, right? But that is kind of what we're talking about here. This basically outlining the precise steps you're going to do anything that provide any service that you do. And now we're going to take that to the cloud, and when we're saying, okay, when we're in the cloud and we're setting up VMs and VPCs and load balancers and things, here's how we're going to do it. Right? This is what we're going to do. Okay. So the run book needs to provide sufficient detail, right? When we started, like it was bullet points, right? 3 or 4 things, and then, then somebody would correct it or add to it. And then we would go and add some other supporting documentation, and we'd have this nice, sufficiently detailed policy for a procedure for whatever we need to do. The idea of this, and that's that 4th bullet point, this bullet point, right? Whoa, not there, right here. Where is my mouse? My mouse has disappeared. Right here. Allow people to follow the steps and obtain the exact same results each time. Okay. Super, super important, right? If you want to provide the best service that you can for your client, make sure you're doing it the same way for every client. Okay. So that you have the same results, right? And then if there's a problem that can be addressed, right? Everybody's familiar with how we did it in the first place. Okay. Now, once we had that book created, right? It took us 4 months to get it created, right? And part of the process was if something needed to be changed, that would be then highlighted in a meeting on Friday mornings. Okay. Keeping it current, keeping it well organized, keeping it accessible by the right people. Okay. So we had at one point we had a lady and one point we had a gentleman, but we had somebody, we had a person that would take all inbound phone calls, right? And so they'd take all the inbound phone calls to the help desk, and they would then, enter information into the database, into the ticketing system, and then distribute the tickets to the appropriate technician. Okay. Part of their job was to make sure that we kept this thing organized, that we kept it accessible, and that it got entered into our content management system. We had a knowledge base, right? So all of this eventually from paper became digital copies, right? And then once that started happening, then any updates that needed to be done were then managed by the inbound phone call taker. I don't even know what to call that person at this point in time, right? They're just level one. So they're not even level one support. Like they're pre-support, basically taking the phone calls, making sure we get the details that we need, assigning, they had to understand kind of what's going on so they could set a priority and they could get it to the right person. But that person was then responsible for all of the management of this book. Okay. We had a physical copy of the book and we had the copy in the content management system. Anytime we made a change, a change was made in the content management system, and then that was then printed and put into the book. Okay. And that was the responsibility of that particular individual. So at that point, once we got to where we had it established, and then any kind of debatable changes, those became still part of the Friday meeting. And then that person was responsible for, here are the procedures that were questioned this week. And here's the ideas that we're thinking about and what we need to change. And then we would all agree. Or we would work on that procedure right then and get it updated. And then it would be ready to go by Monday morning. Right. So it needs to be designed to be read and followed by humans, right? That'd be great. When you say humans, we think, well, IT professionals, right? So because a book read that could be read and followed by an IT professional is going to be different than a book that can be read by a cashier, right? It's different, right? So I mean, there's a degree there of difference that this has to be read by the people who are actually going to implement it. Okay. Eventually, the idea of these policies and procedures is then as we get these procedures on lock, how do we turn them into a computer language? How do we turn them into a scripting language or a programming language where we can then automate these processes and procedures, right? So installing antivirus, it used to be we had to send somebody out and install antivirus, right? We had a system that would do it automatically, right? We just need a procedure for when somebody calls and needs that, how do we send that out? Then we came up with a procedure. How do we find computers that are already under our support that are missing the latest updates for antivirus, the latest dictionaries, right? All of the, whatever's missing, how do we install it? How can we do that automated, right? Because eventually it became our level one support, right? The individual that would stay in the office and kind of handle, password changes and things like that. They could fire off a ton of these scripts all day long and do a ton of stuff that field workers used to have to do. We don't have to do that anymore. Okay. So turning it into code, right? Or applying the runbook concept into an automated environment becomes the next kind of evolution to this process, right? Eventually, what your hope is, right, is that your system would then, and I'm using antivirus as the kind of the main thing here, but it can apply to anything else, but right, there's systems out there, like we had a system from a company called Kaseya, and we could easily set the Kaseya system up to do an asset inventory of all the machines on the system, to check the latest updates for the antivirus. What version of the antivirus are we running? What definition files are we running? If you find a machine without antivirus, install it automatically. Like don't even bother me with it. I just do it. Every day at 8 o'clock at night, scan the network, look for anybody without antivirus, right? Install it. Okay. Create a ticket, install it, double check that it's installed, close the ticket, right? We just got credit for work that we didn't have to do by hand, okay? Find antivirus that's out of date, right? Update, create a ticket, update, close the ticket, right? Find definition files, machines that don't have the current definition file, install the new definition file, create a ticket, install a new definition file, verify that the definition file is there, and then close the ticket, right? So every night, right, the system would get 10 or 15 tickets done for us, automated, installing antivirus, keeping it update, right? If any machine got, a virus, right, it would be alerted. It could quarantine the virus, the suspected virus. It would alert, the help desk, and then we could assign a person to log in to troubleshoot that, right? I believe in time you could probably have that done automatic as well, right? But it's one of those things where over time you start to weed out the technician from the really basic things, right? Installing antivirus and updating antivirus is really a basic process that can easily be automated, right? And you save your people to deal with things like, physical printing not working, the database isn't accessible, like things like that, like things that are problems, right? And you let, and again, we talk about maintenance. I keep kind of looking at maintenance things. Anything that's maintenance wise that allows the system to run better, right? Automate it. Automate. Right? So automation accomplishes a single task, creates a VM, installs antivirus, updates the definition file, right? Those are automation. When we use the word orchestration, right? This is going to be the process that I kind of just talked about. Like, I want you to scan for machines that don't have antivirus. I want you to scan for machines that do have antivirus but don't have the current version. I want you to scan all of those machines that have antivirus, current version or not, and see what the definition file is. And then from each of those, there's different steps that I want you to take, right? So then when you put all of that into one automation process, right, a workflow that would every day check, and then even, the workflow could even include, hey, scan for viruses once, scan for viruses, run a virus scan when the machine's, been idle for more than 3 hours, and it's after 7 p.m. at night, right? Run, and we pick, do 20% of everybody every day. So every 5 days we would be able to scan the entire network for viruses, right? And then if you have viruses, and do these things, like that whole thing, right? From a sysadmin support standpoint is called orchestration. Okay. Now in the cloud environment, orchestration would be, I want to launch a testing environment for a new application, and we're going to use the same kind of testing environment that we've used the last 22 times that we've launched the testing environment. So we have orchestration set up to set up the VPCs, set up the virtual switching, set up the virtual routing, set up the load balancing, set up the VMs, set up the databases, set up the storage, right? Set up the security, set up IAM, right? All of that stuff can be automated, right? And then when somebody, the devs call and you say, hey, we need a new test environment for a new app that we want to get testing on next week. And you're like, okay, no problem. Click, 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 boom. Right? You call them back a half hour later. Okay, you're ready, right? Because I have it automated, right? It's ready to go. I don't have to do it by hand. I'm not working over the weekend so that you have systems working ready for Monday. Like literally, even though you did call me at 3 o'clock on Friday, right? Before I leave, right? On Friday afternoon, I'm done because I have it automated through orchestration. Okay. Does that make sense? This idea that, automation is one thing. Orchestration is when you bundle a bunch of things together, right? And then we're gonna, not really harp on this, but we do want to stress the point, right? Documentation and designing infrastructure as code enables more consistent environments throughout the process of application or service development, testing, deployment, and patching. Okay. If it's documented and you're following the documentation, you're going to have more consistent results. Right? More consistent system deployments, more consistent end user experience. And typically with all of those, you have far fewer error issues to deal with, right? Far fewer issues to deal with. Okay. All right. And with that, with the exception of maybe being able to give them different names and things like that, you'll have a nearly identical environment for the app every time, as close as you can get to the final production environment. Okay. So it's infrastructure as a code will make everything consistent and easy to deploy and less likely to cause problems. Okay. There are some different environments that we need to kind of look about and think about. And this is more when you're starting to get into what we call DevOps, right? Which is combining development and operations. Typically, right, folks in my classes are operations folks, right? And then people that are in, say, Rob Gardner's class or Yvonne Nelson's class, they're going to be the development folks, right? So when you work at a company where your company relies on software, right? Your product is software, or your company, it has software that needs to be deployed in order to earn income. Your job as the ops, right, operations, is to make sure that the dev folks have their environments set properly so that they can actually do their work. Okay, so there are four stages that we are four kind of environments that we use in this kind of situation. Okay, the first one, development. This is where the app is being developed or changed. So that's going to be the kind of day-to-day system that the developers live in. Okay, then there's a staging, right? So this is the testing, right? So that we want to launch a test for this app, and we need these kind of configurations, and wham, we got a testing environment, and now we can put the app there. We're not making changes to that app. We're testing that app for problems to make sure that it's quality stuff, that it's not going to break, that we don't have any bugs, that kind of thing. Okay. Once you have an app that you've developed, that you've tested, that you believe you've removed all the bugs from, right? And you all know, right, based on the amount of updates that are sent out on a daily basis from every single app in the world, right, that there's always going to be bugs. It's almost impossible not to have bugs. Okay. Once you have the app as best as it's going to be and it's ready for end users to pay you to use the app, right, then we go into production, right? So we have a production environment. This is the active version of the application. This is where the users interact with this, right? So if you're deploying, say, a Minecraft server, right, and you have end users connected to the Minecraft server to play against each other, that's production. If you have a Minecraft server that you're testing and maybe you add a couple friends in so you can see how things work before you release it out to the general public, that's staging. Okay. And then there is a separate system that we would create called duplicate production, right? So we would take a copy of the production environment and we would set it up separately, right? Not accessible by end users, but we could further test it. Or if an end user has a problem, we can test in the duplicate production environment instead of in primary production environment, right? There's always kind of funny sayings about, no worries, I'm working on the production system, right? Anytime a coder is actually coding the production system, you are asking for trouble, right? Asking for trouble. Prime example from a CNM example, the first year we went to Pi Wars, one of our students took the robot the night before the competition and made changes to how it operated on one of the contests, and we completely had no idea what was going on when we ran the code because it wasn't what we had tested and planned before, right? So instead of doing that on the test system and using a separate SD card to test it to see if it worked, he played with the production system, didn't document what was going on, and we completely toasted that particular challenge, right? So that was not a big deal, right? Because that did, that nobody's life was in danger because of that, and just pride, right? But right, you don't mess with production, right? Once you send something into production, you work really hard not to mess with production, right? If you need to replace something in production because it's broken, you don't fix it in production. You fix it in staging, you fix it in duplicate, and then once you've tested that, you replace production with that. Okay. So they have this thing called a blue-green deployment. Sorry. There's an active environment and there's an environment that's waiting on standby. And the picture kind of looks something like this, right? So we've got a router load balancer. This is our app. This is our production environment. This would be our backup production environment. We make changes here. We test here. If we feel comfortable that this environment is now functional and can take on end users, we can flip blue and green. So this becomes blue and that becomes green. Okay, this is still the old environment. And if something goes wrong here, we can revert back to the old environment. Okay. Does that make sense? So that's just one of the ideas. And we as sysadmins would be responsible for making sure these environments match, that we have the right code here and the right code down here, that we have the right access here and the right access here, right? That kind of thing. So our job is in the background to make sure all these things go along smooth and easy for everybody else that's using them. All right. So IAC, so we're talking about properly synced and updated, maintains consistency, maintains information on the state of the cloud environment, environmental changes tracked by text file versioning, right? So a lot of this is cool because as things are changing, it actually keeps, we keep versions of the older stuff so we can roll back if we need to. Whoa. I just jacked up my headphone there. Sorry. Let me fix that. Okay. But one thing to come out of this, right? Consistency, right? We could have just said IAC ensures consistency and this slide would have been perfect, right? That's the goal of IAC is once we have it right, we can deploy over and over again consistently throughout. Okay. Now, automation tools. Each of the cloud platforms has built-in automation tools. There are a bunch of third-party vendors out there that do a lot of stuff with the APIs of all the different vendors. Most of these tools are managed through the CLI, so you're not clicking and pointing and doing things like that. You're typing in commands. Most of them rely on some kind of programming language and different file formats. So Python and JSON, JavaScript object notation is what JSON stands for, and YAML, right? So Python, JSON, YAML. May offer a web GUI depending or a cloud portal, right? But primarily managed through the CLI. Most work from templates for managing deployments. So, right, another good thing about having these software packages is you've got these templates that you can base everything on. So things that you would normally have to remember to do are automatically done because they're part of the template. Okay. One thing to be aware of: no one tool meets all automation needs, right? And I think they talk about some tools do provisioning, some do configuration management, but most tools they don't do both, right? So there's you usually have two different tools: a provisioning tool and a configuration management tool. There may be somebody out there that's combined those at this point in time, but as of the writing, that was not the case. Okay. So with AWS, there's this thing called CloudFormation. It is the infrastructure provisioning tool that's provided by AWS. It's how you manage your IAC infrastructure as code through the AWS interface. Okay. So this allows you to create templates for your AWS resources and deploy the templates as needed. Okay. Templates are machine readable and human reader friendly. So they're pretty cool. Azure Resource Manager is Azure's version of this infrastructure provisioning tool. Handles all resource deployment and management in Azure, includes resources managed through the portal, so PowerShell, Azure, CLI, REST APIs, right? The template comes in a JSON file format. And it looks something like this. GCP has Deployment Manager Infrastructure Provisioning Tool. You can create configuration files to repeatedly deploy many resources in parallel. So if I have a configuration file for a particular VM, I can launch it multiple times. Right? You can track individual resources for deployment in templates. Templates serve as building blocks. Like you're starting to see this theme, right? Templates, templates, templates. Documentation, documentation, documentation. Okay. Outside of the primary cloud service providers, there are other software providers out there. One of them is Terraform by HashiCorp. So it's cloud agnostic infrastructure provisioning. It's open source with an enterprise version available. So whenever you see enterprise version available, that means paid version. It kind of works with you. You create a plan using human readable configuration language, right? Human readable configuration language. Compatible with JSON. So you write the plan down using their language, and then it converts it into JSON, or it works with JSON. Then you apply the plan to deploy the configuration to a cloud or multi-cloud. Okay, meaning you can tell it this is what I want, and then you can say, hey, fire me up a VM on Azure, AWS, and GCP, as well as 150 other online providers. Okay, so this one's pretty popular, Terraform. So it's going to be a provisioning tool for setting up and deploying virtual hardware, virtual services. Ansible. So this is open source, but not free, right? So it's owned by Red Hat. Does anybody know who Red Hat's owned by? Red Hat's owned by IBM. Right, and it is probably will probably become one of IBM's biggest revenue streams. Right, Red Hat is the enterprise edition of Red Hat Enterprise Linux. Has been around forever, and it is a pretty big deal in the Linux world. Right, so Ansible doesn't require. Sorry, doesn't require agent on the managed nodes, right? Let's see, connect to managed nodes by SSH by default. I'm sending to should be doesn't tell if it's a push or pull. It'd probably be a push. To automate changes, create a text inventory file containing definitions of variables for managed machines, right? And then create playbooks to orchestrate automation of multiple nodes. Okay, so Ansible, open source, usually Linux based. Allows you to do provisioning of systems, and it works with all of the Ansible works with all three of the big cloud service providers. The next tool they want us to know about is the Chef CM tool, configuration management tool. It's an open source tool. Can be used to configure a large number of nodes, such as servers and networks, on both on-prem and in the cloud. Right, so that's kind of neat. It's built on Ruby. Right. And configurations are stored in recipes, right? They're not called templates, they're called recipes, of course, right, Chef? And then they're grouped into cookbooks. Okay, so then, right, so a recipe would be automation and a cookbook would be orchestration. Puppet CM, it's similar to Chef, it's been around longer. It uses a domain-specific language. It's based on Ruby. Trying to see the enterprise free version up to 10 nodes. Puppet and Chef rely on agent installed on each managed node. So these are both agent-based, meaning there's a piece of software that sits on the computer or the service, and it will check in with the server and say, hey, do you have anything for me? And it will decide to go, if it does, then it will run that information. All right. Salt stack. So this is event-driven automation. So it detects problems and enforces the desired state of managed resources. So you say, this is what I want my system to look like, and it will look for problems. And when it finds problems, it will then react to those problems however you have determined told it what to do, right? You do have to have an agent. They call it a minion on managed devices. Bidirectional, so between minions and the salt master. Right, so minions and the salt master will communicate both directions to get and receive instructions. Right, so it actually looks like it'll use YAML, JSON, and other formats as well. So it's kind of looks like it's rather flexible. And open source and enterprise versions. So should be free version and costly version. Right, so there's some automation tools, right? So we've talked about provisioning tools earlier, right? Let's go back over here, right? So this is a provisioning tool. CloudFormation is a provisioning tool. So Amazon has System Manager, which is a configuration manager. So this is where we would set up and manage our templates and our configurations, okay? Azure has an automation called Azure Automation CM tool. It does the same kind of thing. Okay, so the point of these CM tools is that we would have the ability, like so you can see with Azure, it says it enforces a desired state. So we say this is what we want our VM to do, and here's the parameters it needs to stay within, and it would then keep that system within those parameters. Okay, so it manages our configuration. So these two are configuration management tools. All right. There's one last concept called differentiating factors. This is what I kind of mentioned a minute ago, push model and pull model, right? This is easier to look at it here. So I've got my configuration managed server. What it will do is it'll send out a message to the managed node that says, here's your new configuration. So the second one here, I want you to change these three things, right? And that'll be pushed from the server. So once I've got it set and tell it to save, then it should push out to the managed node, and then the managed node would do its thing, okay? You also have the pull model, okay? And the pull model allows you to ask for configurations, right? So the management system that we used to use was a pull model. So we would put an agent out here on the managed nodes, and every 90 seconds, they would send a message out the firewall at the location to my server, which was internet forward, right? So these machines could get to it from the internet. They didn't have to tunnel through a firewall. You didn't have to open up ports or anything like that. And the reason why this would work is in all of my customers' locations, I wouldn't allow traffic in unless it was started from the inside the network. So if this managed node says, hey, do I have any configuration? And my machine says, yeah, here's what you need to do. That's part of the conversation, and that'll get through the firewall. Okay. So pull. If you're doing a push, right? Firewall, if the firewall's here, these machines, these nodes would never see the information, right? Unless we've opened up a hole and and done the appropriate things for that. Okay, so something to be aware of. Push and pull. Immutable environments or resources that are not changed after they're deployed. So if we put once we go into production, right? To me, production is unmutable or immutable, meaning I'm not gonna change it. It can't be changed. I can replace it with something else if we've tested and we have a proper reasoning for doing that. Okay, they are not to be modified or messed with. Okay, and then I don't know if that's the right thing, right? IDM I don't even know how to say it. I sound ridiculous. Which means that you can run the configuration and it will make the needed changes to the environment without destroying the existing resources. Okay. So immutable, we're not making any changes after it's deployed, right? If we're whatever this, however you say this, right? If we're that, it sounds like you can make changes and see what it does, but you don't actually mess up the existing state of the system. Okay. Kind of goofy. All right, so we've got in the last little piece, differentiating factors, imperative tools versus declarative tools. So imperative tools give the exact steps you want to take it in order. So when I do an installation of antivirus, you do this, 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 this. Okay. Um, whereas declarative, you say, I want to have antivirus installed on this machine, and the machine will figure out how to accomplish it. And how it gets there, not worried about that, right? So imperative, I give you step by step by step, right? So think micromanage, right? Right. Um, I want you to open the box with a blade like this, and do this, and do this, and do this, and do this, like step by step by step by step by step. Okay, that's imperative. Declarative is, hey, here's some boxes. When you're done with it, I want to have all of the clothes hung this way, this way, and this way. And then I leave. And then my uh, my goal for you is to have that done the way I asked it to be done, without me telling you all the ways of doing it. Okay.